Hello everyone, this is Smorn. Today I'm just going to be going over Crackme, and it's got a little bit of anti-debug, a little bit of obfuscation, but I'm just going to kind of walk through how I would normally look at something like this. I'm going to be using IDA and x64 debug, so just IDA freeware, no hex arrays, decompiler, or anything. But I'm just going to kind of walk through what you should be looking for, how to deal with a little bit of anti-debug, and how to kind of make sense of the obfuscation in the programs. So I'm just going to start off by running it in command prompt. And so you'll see it wants a username. Just type in the username. It wants a password. Just type in a password and wrong key. So this is really the whole functionality of the program. There's really nothing else to it. If you get it right, it'll say something along the lines of write a keyjet now. So no GUI, none of that crap. Just keep it nice and simple. So I'm going to go ahead and throw this into IDA. And I'm going to assume that everyone watching this video, as this is a little bit more advanced, is kind of familiar with all this stuff. So I'm not going to go like into too much depth of all these options and kind of how IDA works, but I'll show some stuff. So this just stays the same, and we're not using a PDB, so we don't have to worry about that. And IDA will take us right to the entry point. So the first thing, if you're not really sure what's going on, is, and really in any sample, you should come up and you should take a look at the strings. So this is just pretty good practice. So under view, subviews, strings, you can open up a strings window. And in here, the first thing I see is username, the username length, password, and debugger has been found. So just by looking at this line right here, I can automatically assume that they're going to be doing some checks for debuggers. So I'm going to keep that in mind. And I also have a little notes file, which I'm going to write in. I'm just going to take some notes for when we throw it into x64 debug. But for now, I really don't see anything that's telling me, okay, this is the right password or congratulations. And I don't even see that wrong key string. So I want to keep that in mind because they might be doing some sort of dynamic decryption with that stuff. Just keep that in mind. Nothing, not too big of a deal. But jump back to the main function. The first thing that really catches my eye is these debug checks. So looking at what these are doing, essentially, it's calling is debugger present, which returns a boolean, and it's testing this, and jump if not 0 to here. So if debugger is found, this will return true. It's going to test it, and if the debugger is found, it's going to go to this stub right here. And so we can assume that this function, check remote debugger present, if a debugger is found, jump with 0. If this is not, if this does not return true, we can assume that a debugger is also found. So I'm going to jump in here and just kind of check this out, this little stub, and you'll see I've already found the debugger has been found running string. So I think it's safe to assume that this is debugger found function. You can see it's clearing the screen, debugger has been found, it's pausing, and then it's exiting the process. So I'm just going to go ahead and click N and rename this to debugger found. So I'm also just going to kind of look through this real quick and see these functions are being called kind of everywhere. You know, debugger found. So, and they seem to be using the same two functions every time. These check remote debugger present or is debugger present. And we know if this returns true, it's going to jump here, and if this is somehow false, it's going to jump there. So I'm going to type in the notes is debugger present or opposite of check remote debugger present. So I'm going to keep this, and this will really help us once we get into x64 debug, just kind of crack down on all the detection mechanisms. This is a good start. Next thing I'm going to look for, I'm just going to kind of scan through everything. So just doing these checks. If it wasn't found, we're going to come to here where it's provide a username. And this whole part with what I'm doing in IDA is I'm essentially just looking through everything to see if I can find any interesting info that I want to save for later and kind of get a feel for what's going on in the actual process. I'm not trying to solve the actual Crackme right now. Just kind of getting a feel for everything. So let's see. This string is loaded into RCX. It's formatted, and then we're calling this function. We're moving this register into these stack variables, calling this function, which you can see vprintf. So we can assume this is our print function. We're going to print format. So this is what's printing provide a username. And then we appear to be loading a stack variable into RDX. We're loading this format %s, so it wants a string into RCX, and then we're calling this function. So this function vscanf, it essentially, and we can see up here, it takes a format. So this %s is the format, and it wants a string. So we know that provide a username is looking for a string in return. So that's important. So under username, we're going to put it wants a string. So now that we know that it wants a string, I'm just going to kind of go through here and see what else it's doing with it. So I'm going to format the string with this function, and it's going to load it into RCX, and then it's going to move this into racks, which essentially is just -1 because you have to take the 2's complement of the number. So exchange the lower 16 bits of racks. It's going to increment REX, compare RCX plus REX dereferenced and RDI lower. So, and then it's going to jump back here. So essentially what this is doing is this is just kind of looping through each character in the string. So we know that this is holding the actual string, and then this is just an index. So we're setting it to essentially 0 by this point, and then RCX plus 0, and we're checking if it's valid. This is another way to kind of check if something's not null. So it seems to just be checking how many characters are in the string, and if it is not null, it's going to jump back to here and increment. So essentially just repeating this until it gets to the final character in the string. So we know that this, and I'll add a comment here. Where can I do that? Just gonna I'll just rename this little stub loop through. All right. And then once it's done with this, so once it finds no more characters, it's gonna come down to here. It's gonna subtract 5 from the index, and then it's gonna compare the index to 19 in hex, which is really just 25. So this jump right here, jump if unsigned above, is basically saying it's going to compare the two unsigned values of these numbers. And so it may be easy to think, okay, you're just going to subtract 5 from the index, and then if the index is at or below 19 in hex, so 25, it's going to follow this, and it's good. But the truth is, if the index is negative, the unsigned is going to be above the actual unsigned of this number right here. So -2 would really be something that looks like this with maybe an E with a D here. So the unsigned is going to be much bigger than this of a negative number. So we can really interpret this as anything that's 0 up to 25, up to 30 characters. So we know that for the username length, and just following this down here, we'll see what happens when we get this wrong, but this jumps down to a username length. Yeah, so this is what I would expect here because it's just checking the username length. Where were we? Right here. So username length is out of range, and then it's just gonna exit there. So we know that we need to have between 5 and 30 characters for the username. So between 5 and 30 characters. We could just test this out real quick. I'll just go, and if I type in like 3 character, I'll type in 4 characters, doesn't work. If I type, if I, Jesus, if I type in 5 characters, it does work. And I'm not going to type in 30, but we can assume that we'll trust this logic. So now we know a little bit about what we want for the username. Go ahead and make a password thing. I'm just going to kind of follow this down here more. So we still have the actual username in RCX at this point. And you can see we're loading another stack variable into RDX, and then we're loading this into RCX. But this variable is the same. This is what's holding our actual string, the formatted string. So we know that RCX is really just going to be holding the same thing after this call. And then we are calling into this function right here. So let's check this out. And see a couple of debugger present functions. Check remote debugger present is debugger present. Let's see, we already have this marked. That's nice. Then it appears to just be doing some kind of bitwise encryption stuff. Just gonna kind of scan through this because there's really nothing too interesting. A couple loops. It's maybe yeah, just incrementing. Well, quite a few loops actually. Bigger loop right here. That might be of interest later, or that could just be. Yeah, this is quite long. Okay, check remote debugger present, another debug check, and then it's doing quite a few bitwise operations and then returning. So this looks like it's doing something to kind of encrypt the username or hash the key. So it's important to keep that in mind. And we had, we know that RCX was holding the actual username when we went into this call. So it's going to be an RBX. Kind of see what they do with RBX. Kind of holding on to it. Okay, so I'm going to come back to this. This looks like, I think it's safe to say that this is some sort of username encryption function. So I'm just going to go ahead and mark it as that right here. Might not be, but it's just kind of how it looks. So let me have a couple more debug checks. Branch off to there. And then we reach this. Type your password. So under my password, we see that moving this onto the stack, it's calling this function, which is a print function. So it's going to be printing this. This is just printing this. And then we're loading this stack variable into RDX, and then we're loading this format into RCX. So this is a unsigned long. So essentially, it's expecting an integer, 64-bit integer for this, and it's going to format that when we call what I would assume is the scan function right here. So it's expecting an integer for the password. This is kind of what I'm seeing here. So %lu, and I'm not going to type that, whatever. And let's see if they do any sort of length checks or anything else. So, this is the scan function, moving it into RBX, doing a couple debug checks, just kind of scanning through this. We're going to be here. Okay, and then it's comparing RBX, which is our password, with this stack variable. So what is this exactly? 88 RDX. Okay, so the way to interpret this for this is you see they're loading these two addresses into these registers and then they're making a call. So I think it's safe to assume that this could be a reference to the encrypt. We know that this is already the string at this point. So this, I think it's safe to assume that this would be some sort of reference or pointer to the actual username that they want to decrypt or encrypt. So we can say that variable 88 on the stack is it's the encrypted username. So they're comparing the password with the encrypted username right here, which is interesting. And then they're jumping if not 0. So if these two are the same, they're going to jump to this stub and do this. And if not, they're going to kind of move this in here and then jump to this final function, which looks like a print function. Yep. So I would assume that if these are the same, this is essentially going to create a string that says that it was correct. And this looks like it would be doing maybe the opposite. This is probably going to be the wrong key. And in x64 debug, we can kind of walk through this and it'll automatically do all that stuff. So we won't have to kind of put this all together. But um, um, yeah, it's just kind of loading these bytes in there. So this is probably what's containing the string right there anyways. But it's no big deal. We kind of got a feel for what it does. So essentially, and there's no check for the password length, so we know that. No length check. Essentially, it's comparing password with encrypted username. And under username, I'm just going to make a little note that maybe wants a string encrypted username and maybe string username. I don't know if it's could be in that order. I don't know which way did they push it. Okay, so this would be more like this would be reversed. That should be like that. Okay, so we kind of have a good idea for what the program's doing now. It's doing these basic debug checks. It's checking the username between 5 and 30 characters and it's formatting it as a string. It's encrypting it. It's encrypting it into a encrypted username variable that's being passed to this function. And then for the password, they're really just, they're expecting some sort of key in the form of integer or a long, and then they're comparing the password with the encrypted username. So that's a lot of information just from kind of scanning through IDA without really going through each individual um, instruction. You know, we're able to really easily pull, okay, they're using these calls for debuggers. They're using these same calls to print and scan. They're kind of doing the same thing. They're just formatting before and passing to this format function. They're looping through the characters, and then this function is probably going to have most of the actual what we're going to need to make the keygen. So, but based off this information, I think it's a good bet that we can go and throw this into x64 debug. So go ahead and throw it in there. Okay, and before I touch anything, I want to go and patch these debug checks. So the first thing I'm going to do is we know is debugger, Jesus, present, and oops, sorry about that. You'll see we're kind of at this little stub here in kernel base. And so we're just going to jump into this little stub and then we get to the actual function. And here you'll see it's not a very complex function. They're moving this quad word pointer into racks and then they're checking a certain index. So this is some sort of structure. And this is actually the PEB. The PEB is at offset 60 on 64-bit processes from the GS register. And in a 32-bit process, this would be D word pointer FS in the FS segment register at offset 30. So it's pretty similar, but just given that this is given that this is a 64-bit process, we would expect this for the process environment block. And then it's moving the being debugged flag, which is at offset 2 in the structure, into EAX, and then it's returning. So there's a couple ways you could patch this, but if you click space to assemble, a really easy way is just to make sure that EAX gets 0 every time. So move EAX 0 is good enough, and then we can just return. So this is good enough to patch this function right here. And now we need check remote debugger present. So again, just a little stub, jump in there. And this function's a little bit more complex. So we wouldn't really want to go through and check out what they're doing. They're calling NT query information process, they're returning a structure, and it's kind of a pain in the ass. So a cool trick with this function is you can just return and you don't have to worry about it. Because again, they're checking if there's nothing returned at all. So um, this is sufficient enough for what we're trying to do. So now to jump to the entry point, you can just come up here and click run. There's already pre-placed breakpoints. And now we're at the entry point. And you'll notice this doesn't really look anything like what we've got in here. This does not look like the entry point we had earlier. And sometimes there are these little initialization entry points or functions. Could be compiler related, could be that they're trying to hide stuff from us for static analysis. But the best way to get to the actual entry point in a case like this is just to look at string references and follow. So we know that the string provide a username is in the main function, and we obviously don't see that through here. So if you right click, search for current module, string references, it'll open up the strings window. And now you can see that we actually have provide a username, password, and kind of all these strings. So it appears that maybe those entry functions kind of decrypted these values. So that's important. And this gives us a lot more information. So we know if we wanted to look at where that comparison is, we could go to these strings. But I'm going to start off just going to the main entry point, and I'll double click on this string and it'll take me here. And let me kind of analyze this function. See, this is from an earlier take, but I'll leave that there. Push RDI, sub RSP, A0, move racks. So this looks a lot more like, yep, and this is our actual entry point. So now that we're here, yeah, just have that breakpoint there in case we have to restart or something along those lines. But this is where we want to be. So this is good. And we know that our username, we're going to expect between 5 and 30 characters, and it wants a string. So what I'm going to do now is I'm just going to kind of walk through what the program's doing, just kind of scan through it. And then I'm going to show you guys how you'd patch it if you're just trying to patch the program or kind of see like what's being compared. And then I'm going to go back and I'm going to actually analyze that encryption function in IDA, and I'm going to show you guys how to write a keygen for it. So I'm just going to write a simple C++, maybe C keygen function, but I'll go through like what you would do if you were trying to do either one. So assuming that we're just trying to patch this program now, I'd kind of come down here, look, provide a username. This is the call for print, and this is the call for scan. So if I set a breakpoint here, actually I'll set it here, and I run, you'll see it shouldn't hit it because we hit that. If I run again, it's not going to hit our breakpoint because this scan function essentially waits and holds the process thread. It holds the thread basically hostage until you get a return in the input. So I'm going to go ahead and type in something like truth RE, and there's our breakpoint hit. We didn't have to do anything. So looking up here, we'll see RCX is holding our actual the actual name of what we typed in. And we know from IDA that that was expected. So they're moving RCX, this stack variable, into, sorry about that, they're moving this stack variable into RCX. So we know that that is holding the username. So that's what we would expect. And then we know that this chunk right here is really just checking for the length. So this is the, you'll see this jump. If we follow this jump down here, it should go down to that username length is out of range right here. So back up here, right here. So I'm just gonna kind of step through this area now. So we step into this, we'll expect Rax FFFFF. It's a no operation. So yeah, the exchange AX and AX really acts as a no operation because you're really not changing anything. So this is just another way to put no op. And the opcode for this is actually 90 as well. If you go to options, general, number of opcodes, the maximum number of opcodes, or the maximum number of bytes in one operation is 15 in x64. So put 15 just in case. And if I go back to this, you'll see 6690. And this is just a prefix. This is this 66 is denoting that this is going to be using 16-bit registers right here. And the 90 is, a lot of people would say this is no operation, but it's actually different depending on, there's different bitwise flags in these. So it's a little bit more complicated than just looking at the actual opcode. But going back to this now, if I step in here and you see increment racks, this then goes to 0. So this is really -1 in sign terms, and then you're incrementing it to 0. And then it's comparing, and you'll see the index, and then it wasn't null, so it's going to jump back up. And then this is going to increment, and I'm assuming this is going to go to RU. This is going to remove the T. It does. And it's going to keep going until it gets all the way to that E. And all the meanwhile, it's counting the actual length up here. And it disappeared, but it's still going, and we expect 7. And then it continues once it gets to 7. So truth or is 7 characters, we know that. It's going to subtract 5 from it, so it's going to go down to 2. And then compare it with 19. We know that obviously 2 and unsigned is less than 19, so it will do this jump. Excuse me, it will not do this jump because it's jump of unsigned above. It's gonna go over it, and then it's gonna load into RDX this stack location, which is emptied out. So you can assume that this is just another initialized stack variable that doesn't have a value yet, or a pointer. And then it's gonna load this right here, which RSP plus 70, it's going to load this into RCX, which I believe, yeah, this RSP plus 70, this is our, the username that we put in, actually. So, back up to here. Yeah, okay, cool. And then this is going to be that encrypt function. But we're not really worried about this right now. I'm just going through and gonna, for this run through, I'm gonna kind of just go and show you guys how you patch this if you wanted to. So it's kind of jumping through here. Type your password. It wants an integer. So we already typed the username. Let's run till we get to here. And it's gonna stop again because it's trying to scan. It wants our password now. So I know that it wants integers. So I'm gonna type in just a bunch of random shit. Enter. And you'll see if I step through this, RBX is holding this, which really is just, should be the hex value of this. So our key that we put in, our password, is now an RBX. And we're gonna come down here. step through this. We can actually just jump down till we get to, where do we want to go? Right here. This is our compare that we were looking at earlier that compares if this is this compare right here that's comparing again our encrypted username and the actual password we put in, and obviously the password is already in RBX, so this all makes sense. I'm just going to run through it till we get to there. And so it's comparing RBX and RSP plus 20. So RBX is holding this value right here, and RSP plus 20 is holding this value. So this we can assume is the encrypted username of truthRE. This is essentially the hashed username of truthRE. So I'm going to take this. So to patch this now, essentially we've got 2 bytes here and it's checking to jump here. So we just don't want to take the jump under any circumstance. So I'm going to go ahead and assemble, and I'm going to put a good little 2 byte no operation, like I was saying earlier, is exchange AX exchange like that, and we can put this in, and it comes across as no operation. So now if we step through this, it's going to compare these, and it's going to jump over, and it's immediately going to come through here. So if I run the rest of the program now, you'll see nice one. So essentially we just patched the program by fixing these bytes with exchange AXAX, or no operation, 2 byte no operation. So if you want to patch the program, you could just save this now. You could just patch the file. Okay, now what I'm going to do is I'm going to throw this back into x64 debug, and I'm just going to kind of walk through or get it a little into what they're doing to encrypt the actual username. So I need to patch the actual debugger checks first. Come here, return, just the same thing as earlier. Just patching these functions, 0 and return. And I believe, yep, our breakpoint is set from earlier. So entry point, and then our actual entry point breakpoint. So we're at the actual entry point now. And so have the breakpoint right here, right after we get our input username. So I'm going to run to there. It's going to ask for our username. I'm going to type in truthRE. And you can see truthRE is right there. I'm going to come down here, and our next breakpoint is at the compare of our password and the encrypted username, like we said earlier. So I'm going to run to that. It's going to ask for a password. I'll type some random shit in. I'm going to come down here, and you see we've got our password that we typed in. And to show you guys, if I copy this, this is just the hex representation, and I opened up a calculator here, and I put this in, you'll see the, swap. You'll see the hex 346AF is the same as it is up there. So that's the same. And then if we come down here, you'll see what it's comparing it to. This is going to be the encrypted value of the username we put in. So I'm going to go ahead and copy this. Come up here. I'm going to come in here, swap this, and put this in and get the decimal version. So I'm going to copy this, and just to make sure that this is all working properly, I'm going to rerun the program. Run it. I'm going to run to first breakpoint. Run again. Oh shit, I gotta patch the debug checks. Don't forget about that. Really do make it much more annoying, but probably should have just patched the file before this, but it's really not a big deal. Okay, so I'm gonna run to our actual entry point, and it's gonna ask for the username, which I'm gonna put in truthRE, and then keep in mind this is an unpatched version, so we haven't. This isn't the patched version where we just knock this out. We're just going to use the key that it gave us from last time. So I'm going to go into the password and I'm going to put in the password that we pulled that's being stored on the stack. And if I enter this and then run, you'll see, nice one, now make a keygen. So we know that the value being stored on the stack right here is the actual encrypted username. And really all they want is they want you to input the username and the password just needs to be the hashed version of that username. So all the logic that they're doing to hash is really being done in this function, which if we look in IDA, the encrypt username function, which is right here. So x64 debug, that would be right, excuse me, that would be right here. So this function is going to have everything that we need for our encrypt username function. All right, guys. So I think I'm going to end the video here. Everybody's being a bunch of little pussies in the Discord, asking for me to finish it up, and it's gotten kind of long as is. So I think what I'm going to do is I'll probably create another video with the keygen and just kind of walk through that in C++ and show how you go about doing it. If you guys like the video, just give it a thumbs up and comment what I should change, given that this is the first video. There's probably a lot of shit I did wrong, and it probably wasn't great, but if you guys want to see anything else, just leave a comment, and I'll try and create a video about it. So join our Discord. I'll put it in the description, and thanks for watching. See you.